Hello everyone, this is Mr. Swapnil Bapusaheb Herwade, lecturer in Institute of Technology, Polytechnic at Rao, and I am here with practicals. Okay, so in this lecture we will see the introduction to the labs, okay, and the laboratory equipments and what the practicals we have in mechanical engineering materials subject. Okay, so see, as you know, every subject has some outcomes that can be called as outcome of the subject. So we also have the 6 outcomes of our subject, like identify the properties of materials. Second, select the relevant ferrous materials for mechanical components. Third, select relevant cast iron for the engineering applications. Fourth, use non-ferrous metals for mechanical components. Fifth, suggest relevant advanced materials for mechanical components. And sixth, select relevant heat treatment processes. Okay, so these outcomes can be fulfilled with the help of lectures also, and with the means these outcomes can be fulfilled with the theoretical process also and with the laboratory practicals also. Okay, so in the practicals we have the practical, or we can get the hands-on experience of the materials. Okay, what is the ms, what is the steel, what is the cast iron, so we can get a hands-on practical, hands-on it. Okay, so see, these outcomes also can be completed with the help of practicals. Okay, so next, this is our teaching and examination scheme of mechanical engineering materials. Okay, subject. So see here, this is a practical. For this practical, we have two things, that is ESE, end semester exam, and PA, that is progressive assessment. This end semester exam means you have external practical with oral of 25 marks, and you have progressive assessment, that is term work, for 25 marks. Okay, it means this whole practical assessment is for the 50 marks, where you must get the 20 out of it. Okay, so see, this will be the external oral, that is for 25 marks, and this will be the term work. This can be given on the basis of what the practicals you have done in at every practicals, and plus your submission of your manual, your completion of manual at each practical. Okay, so see, this will be the teaching and examination scheme. Next, what the practicals we have in that, the first practical, that is prepare specimen from given material for microscopic examination. See, we have a material of MS. MS means mild steel, which have carbon from 0.2 to 0.4%. Okay, so this mild steel will be given to you. It will be a spherical one. It may be a rod which has some diameter of 10 mm and length will be a 30 mm. Okay, that will be given to you, and you must prepare a specimen such like it can be seen under the microscope. Okay, so first practical is about the prepare a specimen from given material for microscopic examination. Okay, so for microscopic examination you must have a material which should be have a good surface finish, which must have a good surface finish. For that, to make a good surface finish, you have some papers, okay, polish papers. For with the help of that polish paper you can go for the good surface finish. Okay, then second practical is about use metallurgical microscope to interpret the microstructure of steel. See, to see the microstructure, okay, every material, every ferrous metal, every non-ferrous metal, okay, it have the microstructure. Okay, it may contain the ferrite, it may contain the austenite, it may contain the pearlite. Okay, all these things. To see that microstructure, we have a equipment that is called metallurgical microscope, which is based on the reflected light phenomena. Based on the reflected light phenomena, that metallurgical microscope can be used to interpret the microstructure of steel. Interpret the microstructure of steel. It may be a mild steel, it may be a low carbon steel, it may be a medium carbon steel, it may be a high carbon steel. We can also see the microstructure of the copper, the brass, the bronze, then cast irons. In that grey cast iron, white cast iron, we can see a microstructure of any ferrous and non-ferrous material. Okay, so this is our second practical, that use metallurgical microscope to interpret the microstructure of steel. Next, we have third practical, that is use Brinell hardness tester to determine the hardness of given sample. As we know, hardness is nothing but it is a resistance to wear, and the it is resistance to wear. Okay, then there are three types of equipments in industry, they can be used for the to measure the hardness, that is Brinell hardness tester, second Rockwell hardness tester. Okay, and in our practical we have two, that is Brinell hardness tester and raw Rockwell hardness tester. In that, first we have Brinell hardness tester to determine the hardness of given sample. That given sample may be of mild steel, it may be of high carbon steel, it may be a cast iron. Okay, so the Brinell hardness tester used to determine the hardness of given sample. Next we have use Rockwell hardness tester to determine the hardness of given sample. Okay, so see, Brinell hardness tester is used to determine the hardness of those components which have high thickness, which have optimum hardness. Because in Brinell hardness tester we give the load which is at a high amount than that of the Rockwell hardness tester. Rockwell hardness tester is used to measure the hardness of those materials which is having high hardness, short thickness or low thickness, because in Rockwell hardness system it doesn't give a high load. That load may be in between the 50 kgf, 100 kgf and 150 kgf. As in Brinell hardness system we give the load of 3000 kgf. Okay, so it matters what the load we give to the material. It matters because due to the low thickness and high hardness with the high load, that material may get break. If that material have some crack, that doesn't give you the proper hardness number. Okay, so the hardness measurement is a measurement of the measurement of hardness of the material without crack or without fracture. With a fracture you doesn't get a correct hardness value. Okay, next, use relevant peel tester to determine the adhesive strength of various steps. Okay, so see, if we have any tape, okay, it may be a it may be a, it may be a electric tape, it may be any kind of tape. Every tape have its adhesive strength. If we stick to any material, it have some adhesion to that material. Okay, that adhesive force can be calculated, or that adhesive strength can be calculated by peel tester. Okay, so you can see that in the practicals. And last we have use of box furnace, box type furnace. Furnace means it is a equipment where we can heat any material up to 1200 degree Celsius. It may be a steel, it may be a cast iron. Okay, so a box furnace means a furnace is something where we can heat any material. Okay, so see. So here we use the box furnace to compare the effect of oil, water, brine on hardness of mild steel. See, in hardening process, as we know, we cool the material in liquid media. That liquid media may be a oil, that may be a water, that may be a brine. Its viscosity will change, and that viscosity of liquid media will have some changes in the hardness. That change in hardness, that we will find out. Okay, so last practical is about the use of box type furnace to compare the effect of oil, water, brine on hardness of MS, that is mild steel. Okay, so for these practicals we have major equipments in lab. Okay, so see, first, single disc polishing machine. This is a machine can be used to have a specimen for a microscopic examination. Okay, as our first practical is to convert the given specimen to a specimen which can be used for microscopic examination. Okay, so that given specimen can be well polished with the help of 4 type of polished papers, and after polishing with the polished paper we can go for this single disc polishing machine. You can see here, this is a dish. Okay, on this we can rub that given sample and we can get a good surface finish, and that surface finish will be so good that we can see a microstructure from it. Okay, so this is a single disc polishing machine. This type of machine can be seen in 2 discs also. Means here we have only single disc. In this machine also there is another modification. We can also have the 2 discs at a time. Okay, so this is single disc polishing machine. Okay, next, this is metallurgical microscope. Okay, here we can see the microstructure of any ferrous or non-ferrous material. These are the eyepieces, okay, from where we can see the object's microstructure or the given sample microstructures. Okay, so this whole is based on the reflected light phenomena. Okay, this whole is based on the reflected light phenomena. From these we can change the eyepieces. Okay, sir, we can change it from 10x to 20x, 20x to 40x, 40x to 80x as per our requirement. Okay, we can change it. See, next, this is Brinell hardness tester. Okay, this Brinell hardness tester can be used for measuring the hardness of the component which have high thickness, which have optimum hardness, because here we are giving the load. See, at the end, the, this is what, this is the load we are putting on this hardness tester. Okay, these are the blocks of 250 kg. Here we have total 9 blocks, so it is 9 into 250, plus here all the loads of the interconnections of the 250 kgf, so it have the 2500 kgf load on a given specimen. So here in Brenner hardness tester we put high load on a specimen, so that that specimen must be having high thickness with the optimum hardness, because the specimen with the high hardness and low thickness, it may get crack when we apply the load, and that cannot give you the proper hardness value. To get a proper hardness value, this Brenner hardness tester can be used for those specimens which have good thickness and which will have the optimum hardness. Okay, next, and this is what we have seen. This is in our lab we have the same equipment, that is Saroj made equipment, which is given us by the FI Industries, that is FI Industries. Okay, next, this is next digital Rockwell hardness tester. Digital Rockwell hardness tester. This tester can be used to have the hardness of those materials which have high hardness and low thickness, because here we have only load of 50 kgf, 100 kgf and 150 kgf that can be adjusted from here. Here we have a knob, and on the basis of that knob we can adjust the load. If we want the 50 kgf, we want 100 kgf, we want 150 kgf, we can adjust the load. And here we have a chart. This chart shows which type of tool you want to measure the hardness. We have diamond tool to measure the hardness, we have ball indenter to measure the hardness. That which type of tool you must use, it is given in this chart. That which type of tool you are going to use is depend on the what type of material you are going to use for the hardness measurement. If you are going to measure the hardness of cast iron, you must use the diamond type indenter. If you are measuring the hardness of mild steel, aluminium, copper, then you go for the ball type indenter. Okay, then this is a digital type. Okay, see here, this is a screen where we can finally got the actual hardness value. Here you doesn't want to calculate anything, it gives you the direct value of hardness measurement. In the previous one you have some calculations. Okay, in this Rockwell hardness tester we doesn't have any calculations, it gives you the direct value of hardness. Just you take what amount of the load you want, that is 50 kg, 100 kg or 150 kg. Okay, next, this is box or muffle furnace. This is a furnace where we can use, it can be used for heating any component up to 1200 degrees Celsius. 1200 Celsius means it is below the melting point of cast iron steel. Okay, so in this we can heat any material up to 1200 degrees Celsius and see the what the changes it have inside. Okay, next, this is a hot air oven. This can be, this was in a chemistry lab also, you may be seen that. Okay, so same we have in the MEM lab. This can be used to heat any liquid media. It may be a water, it may be oil. Okay, so this can be used to heat any material up to 220 to 50 degrees Celsius. Next, this is peel tester. This peel tester can be used to have to know the adhesive strength of the tapes. It may be a electric tape, any kind of tape. We can measure the adhesive strength, means how much it can stick to any material, that thickness or that adhesive property or that adhesive strength can be calculated with this of this peel tester. So we have total 7 equipments in our lab. That is, first is a single disc polishing machine, second metallurgical microscope, third Brenner hardness tester, fourth Rockwell hardness tester, fifth that is muffle furnace, sixth oven, and this is peel tester. These 7 equipments we have. Total we have the 14 practicals on that. Okay, so in the next practical we will see the actual hands on the practicals. Okay, so thank you one and all.